Hello and a very warm welcome once again. This is getting to be almost a daily occurrence, so I've decided to change the picture that I'm showing you very slightly by using a different still from a different video, also shot from Traprain Law. Now this view from Traprain Law has caused flat earthers no end of problems over the last few weeks, and things are not getting any better. So I thought I'd give them a bit of a hand by explaining what they need to do about this picture if they are to rescue their flat earth hypothesis. I don't think they can rescue their flat earth hypothesis, but I'm going to give them a hand telling them the steps that they ought to take, or some of them. So before we do that, or as a prelude to doing that, let's look at how to do science. Science begins with an observation of the real world or universe. You might make that with your eyes or some sense or other. You might do it using machines and a combination of machines and your senses and so on. Having observed reality, which is what I did at Traprain Law, you then need to basically have a guess about what causes the thing that you've observed. What is the reason things look the way they do? Why are the leaves on trees green, for example? And so on. Any observation you make, you can form a hypothesis or make a guess about how it might occur. But of course, anybody can make a guess and not necessarily be correct. So to find out whose guess is correct or which guess is correct, you need to test the hypothesis. When we say test the hypothesis, we mean try to prove it is wrong. If it turns out that the hypothesis fails the test, i.e. the test does prove that it is wrong. For example, you might consider that leaves are green because fairies paint them green. I'm not quite sure how you test that particular hypothesis, but if you could test it, you could perhaps find out that it would fail the test. And then you need to make a new hypothesis or modify your existing one. So you might say, oh, well, it's not fairies, maybe it's elves that paint the leaves green. And you can test that hypothesis. And if it turns out that's wrong, you either modify or make a new hypothesis. Now, if your test passes, or your hypothesis, passes the test, for example, if your hypothesis was that leaves contain something, some chemical that is green, and you find that you can extract a chemical from leaves called chlorophyll, or call it chlorophyll, and show that it is green in color, then you have passed your hypothesis has passed this test. And so you need to test that hypothesis again. And somebody might bring you leaves from a tree that is a red color or a coppery red color, not green at all. Now your hypothesis has to change because simply using chlorophyll to explain the color of leaves is not sufficient. By retesting your hypothesis and discarding or modifying your hypothesis every time it fails a test, hopefully you'll eventually arrive at a hypothesis which passes every test you can throw at it. Every test that anybody else can throw at it. Nobody comes up with any kind of test that it fails. And when you've done that, you can accept that your hypothesis is probably true. And you may even call it a theory. Now, flat Earth has an awful long way to go to get accepted as probably true, as we will see a little bit later. This is the process by which science determines why things happen, how they happen. So going back to my picture here, there's a line drawn across at the top of the tower, the central tower here, bridge tower. Now, a number of flat earthers have complained that my bridge towers are not in the center of frame. Well, the solid red line here is in the center of frame, and you can see the bridge tower top is pretty close to it. Not exactly there, but we'll see another one later where the dotted red line is above the solid red line in the center of frame. It actually makes no difference at all whether the bridge is in center of frame or in the bottom left corner or the top right corner or anywhere else in the frame. Because the camera is at 210 meters above sea level, because the bridge tower is at 210 meters above sea level, that's this bridge tower here, just to avoid any confusion, we can say with certainty that on a flat Earth, everything below the dotted red line must be less than 210 meters above sea level. This is a simple geometric fact. Michael Bin here does poke above the line a little bit, and it's 570 meters above sea level. So even there we can see that some 360 meters of Michael Bin, total 570 meters, is having to be condensed into that tiny little peak poking above the line. That doesn't look right at all. But it gets worse because Earl's Seat is 578 meters above sea level at its peak. It's further away, so it appears lower down in the image, but it's on or below the line. All 578 meters are below the line. And the same with Dumbracher, 540 meters. Cairnrock Hill at 413 meters is below the line, and Stronend at 511 meters is also below the line or on the line. On a flat Earth, everything below the line must be less than 210 meters above sea level, and so because we can see these peaks below the line or on the line, we know for sure that the Earth is not flat. Here is another image taken on the same day, a little bit later time. There's the 210 meter line, and it's just above the center of frame in this case. The solid red line shows the center of frame. These white lines use the correct angular sizes and a location for a flat Earth, and show where the peaks of the hills should be if the Earth was flat. That gives you a good idea of just how much different to a flat Earth this image actually is. So as I say, if the Earth was flat, the tops of these 5 hills should be where the white lines are. And they're clearly way, way below that. Now, my observation disproves a flat Earth. So instead of how to do science, let's do how to disprove a flat Earth. We observe reality. The horizon looks flat. We make a hypothesis. Earth is flat. We test the hypothesis. This occasion we use my observation from Traprain Law. And as we've just seen, our flat Earth hypothesis fails that test. So we must make a new hypothesis or modify the existing one. And this is where flat earthers are when just considering my Traprain Law observation. You have to modify your existing hypothesis of the flat Earth or make a completely new hypothesis. Now, most sensible people would now say, well, Earth is spherical as an option to changing the hypothesis. And the Traprain Law observation passes that test, as we have seen. But that doesn't mean it's correct that the Earth is definitely spherical. We must test the hypothesis once more. In fact, as many times as we can. We might find a place where there is a very long stretch of power lines and a very long causeway over water. If the Earth was spherical and water was conforming to the surface of the Earth, then we should be able to observe that curvature by observing the power lines and the causeway and how water behaves. There is such a place, Lake Pontchartrain in Louisiana, USA. And the hypothesis passes that test. We do indeed see curvature of the causeway and the power lines, and by extension, the water. And we can go on to test the spherical Earth hypothesis in many, many ways. These are just a few that occurred to me whilst I was throwing these slides together. And so far, the spherical Earth hypothesis, with a few minor modifications, has passed every test. The minor modifications being the Earth isn't a sphere, it's a slightly oblate spheroid, almost spherical, but not quite. And more recently, a slightly irregular oblate spheroid or geoid. But essentially, the Earth is spherical and has passed every test thrown at it. And so we can now accept that it's probably true. But let's go back to where flat Earth is after my Traprain Law observation. We can get rid of all this passing tests nonsense on the other side and look at what flat Earth situation is. You have an observation and analysis of that observation, and it proves that the Earth is not flat. Unless you can either demonstrate that that observation is wrong, or modify your hypothesis so that your hypothesis of a flat Earth explains that. Your only other alternative is to throw the flat Earth hypothesis out and come up with something completely different for the shape of the Earth. As we've already seen, a sphere works very well, but maybe you think there could be something else. So looking again at our picture of the bridges and the hills in the distance. We need to make a new hypothesis or modify the existing one in order to explain why this is seen. Photograph is impossible to take on a flat Earth, so you must either prove that the photograph is a fake, and that's easy to do. You go to Traprain Law and you take a photograph yourself. If what I'm telling you and showing you here is true, you'll get a photograph that looks like this. And if what I'm telling you is not true, if I have in some way manipulated this photograph to make it appear to support a spherical Earth, when in fact it supported a flat Earth, then you'll be able to demonstrate that really easily with your own photographs. You won't be able to do that because I know exactly what I did and when I did it and how I did it. I simply went there, set up a camera and took some videos and some still shots. You might see slight changes and slight differences due to atmospheric conditions, and you do need a clear day You can see there are clouds in the sky, but the visibility was fairly good on this day. There are plenty of bright sunny intervals. So if you can't discredit or demonstrate that it's a fake, then you need to come up with some explanation for how this can be taken on a flat Earth, i.e. modify your flat Earth hypothesis so that it does account for this observation. Then you're going to have to go away and test your hypothesis, your new hypothesis, if you can come up with one, against all the other observations and demonstrations and tests that the spherical Earth has passed, and show that your new hypothesis also passes those tests. This is what you need to do. And just to finish off, I'll leave you with a reminder of some of the things that we know, some of the tests that a spherical Earth has passed. Earth is not flat. Thanks for watching.